All right, just wanted to make a quick video talking about how to convert from fractions to decimals and then back and forth between decimals and percents. We won't go from decimals to fractions very much. Well, we're actually not going to go that way at all in this course. So we'll just practice going from fractions to decimals and then converting back and forth between decimals and percents. We'll also have to discuss rounding as we go through this process, so let's get to it. For converting between fractions or from fractions to decimals, we're just going to use our calculators for this, okay? And I'm going to use the Desmos calculator, so that's what I have up here, right? The Desmos calculator, which you can access by just going to desmos.com and then clicking on their scientific calculator. Okay, so in this example, if we want to convert a fraction like 5/40ths, right, or 5/40ths, to a decimal, we would just enter it into our calculator as 5 divided by 40. So on the Desmos calculator, you can find 5, and then the little fraction bar divided by 40, and that's it. So the answer is 0.125. Now, you can change that to a fraction if you prefer. So you could call this 1/8. So notice it'll give us the reduced fraction over on this side, and we can toggle back and forth between the decimal and the fraction as our answer. But I'm going to give it as a decimal since we're supposed to convert to decimals here, and I'm going to say this equals 0.125. Go ahead and pause the video and see if you can do the other two. I'll go ahead and give you my answers. So for the second one, I'm going to do 9 divided by 45, and I get exactly 0.2. And for the last one, I would do 7 out of 22. Now this time we get a long decimal number that doesn't seem to terminate. Desmos is rounding the last digit, but really this would go on and on forever. It would be 0.3181818 on and on forever. So I'm just going to use some ellipses to indicate that. But that last example brings up an important point about rounding. Okay, so let's say that you have a really long decimal number and you only want to display 3 or 4 digits or something. In a case like that, we would have to round. So for 7/22, if we wanted to round to, let's say, 4 decimal places, we would say 7/22 equals 0.3181818 on and on forever, and that's approximately equal to 0.3182. Notice that I'm using the approximation sign here, okay, and the equal sign there. And that's because 7/22 is exactly equal to this number when the decimal point repeats forever, but it's only approximately equal to 0.3182, so it's not exactly, and that's why I'm using an approximation sign. You should always use an approximation sign if you have rounded a number, okay? So it's not correct to say 7/22 equals 0.3182. It is correct to say that 7/22 is approximately 0.3182. Now, on the other hand, it is correct to say that 5/40ths equals 0.125 because there was no rounding involved there, right? 5/40ths is exactly 0.125, no rounding involved. Okay, now when you do have to round a number, here's how we do that, okay? To round a number to a certain number of decimal places, we're going to look at the digit that comes after, right after the decimal place that you want to round to. Okay, if that digit is 4 or less, then we leave the digit before it the same and drop all the digits that come after. If the digit's a 5 or more, then we're going to increase the digit that comes before it by 1 and then drop all the digits that come after it. For example, this number, 3.1415, etc., this is approximately equal to the number pi. If we wanted to round it to 2 decimal places, then we would note that the 4 is at the second decimal place, and then we would look at the digit that comes after it, in this case a 1. Now since that 1 is 4 or less, we simply drop all of those digits and say that this is approximately 3.14. Okay. In a similar way, 0.257982, if I wanted to round that to 2 decimal places, I would note that the 5 is in the second decimal place. The digit that comes after it is a 7, which is 5 or more. So I'm going to round the 5 up to a 6 and then drop all remaining digits. Okay, so this is approximately 0.26. I'll let you pause the video and see if you can round the remaining 3 numbers here to 2 decimal places. Okay, now here's my answer. This one is going to be approximately 253.45. This one's going to be approximately 253.55. Okay, a little tricky, but note that the 4 is in the second spot. So we look at the 5. It's a 5 or more, so the 4 goes up to a 5. Okay, and this one would be approximately, this one's maybe the trickiest of all, but it would be approximately 0.10, because the 9 is in the second decimal spot. We look at the 6, it's a 5 or more, so the 9 has to go up to a 10. Okay. We could, of course, round to a different number of decimal places. Instead of rounding to 2 decimal places, we might want to round to 4 decimal places, and that's what this would look like. So this number rounded to 4 decimal places. Let's see. The 5 is in the 4th decimal place, so I look at the digit that comes after. In this case, it's a 9, so that 5 should go up to a 6. This should be 3.1416, approximately. Okay, I'll let you do the remaining 4. Here are my answers. So this one should be about 0.2580. The 79 has to go up to an 80. Okay, this one would be about 253.4545. This one would be about 253.5455. And this one would be about 0.0969. Okay. So that's how rounding works. You'll have an opportunity to practice this in the homework a little bit with a homework assignment. So, hopefully you get the hang of it. You can rewatch this video if you're a little bit confused about that. But that's how rounding goes. Let me just say a couple of things real quick about these 2 answers, because you'll notice that we ended them with a 0. And so let's talk about that a little, because this might be a little bit confusing to you if you're a little bit rusty on how decimal notation works. But sometimes we're supposed to round, and we're asked to round to more decimal places than the number actually has. So an example of this would be like if you were asked to round 2/20ths to 2 decimal places. If you punched that into your calculator, what you would notice is that 2/20ths is equal to 0.1, but that's only 1 decimal place, right? So what you should do in this case is write it as 0.10 to indicate that you've rounded to 2 decimal places. And that might feel a little bit strange. It might feel like, wait, but how come 0.1 is the same thing as 0.10? After all, it's not the case that 1 is the same thing as 10. So how is it the case that 0.1 is equal to 0.10? And for that, just remember that the one way that we would read this number is 0.1, but another way to read it is to read it as 1/10. And this number we could read as 0.10, but we could also read it as 10/100ths. And so to see that those 2 things are the same, here's 1/10, right? We've split this square into 10 parts and shaded in one of them. And here's 10/100ths. We've split this square into 100 parts and shaded in 10 of them. You can see that they represent the same area. So they are, in fact, the same. In fact, it's always the case that we can add or remove zeros to the end of a decimal number without changing the value of a number. So, for example, 2.35 is equal to 2.350, right? And 0.01 is equal to 0.0100, right? So we can add decimal places, we can remove decimal places, and it doesn't change the value of the number. So the moral of the story is, if you're asked to round to more decimal places than the number has, just add zeros to the end of the number to indicate that you've rounded to the appropriate number of decimal places. And this is why on these two problems that we were looking at a second ago, I could have just called this 0.1, but since I was asked to round to 2 decimal places, I called it 0.10, so that I have 2 decimal places present. And here I was asked to round to 4 decimal places, so I put a 0 at the end to indicate that I had rounded to 4 decimal places. Now, on a test, I'm not going to be that picky, but I thought it was worth mentioning in case you're confused by that. The last thing that I want to cover in this section real quick is converting between decimals and percents. I want you to get to the point where you can do this pretty fluidly without having to think too hard about it. And fortunately, it's not a difficult procedure. It just amounts to moving the decimal place around. So if I want to change a decimal to a percent, all I do is I take the decimal point and move it 2 places to the right. So if I had 0.254, I could just move this decimal place 2 times to the right, and I end up with 25.4, and I add a little percent symbol to the end, and that's that. It's just 25.4%. Same thing for 0.0732. As a percentage, this would just be 7.32%. Okay, I'm just moving that decimal 2 places to the right. 1.4 would turn into 140%. Okay, because when I move the decimal 2 places, if I move it there, and then one more time, I have to add a 0 there. Okay, so I end up with 140. And 0.0023 would be 0.23%. Okay, and that's how it works to change a decimal to a percent. If I want to go the other way around and change a percent to a decimal, I'm going to take the decimal point and move it 2 times to the left. Okay. Now, for 37%, there's no decimal place, but 37 is the same thing as 37.0, so there's really like an invisible decimal point after the 7. And if I move that decimal point 2 times to the left, then I end up with 0.37, and this time I'm going to drop the percent symbol. So 37% is the same thing as 0.37. Okay, 2.5% would be the same thing as 0.025. Again, I move the decimal once, and then one more time, and I have to add a 0 there. So I have 0.025. 232% would be 2.32. And 0.03%, let's see, I would move the decimal once and twice, and have to add a 0. So it looks like I would have 0.123 zeros, right, and then a 3. So this is how changing between decimals and percents works. Oftentimes, I will read a decimal as a percentage, so I might see something like 0.572, but instead of reading it as 0.572, I might just read it as 57.2%. And for that reason, I would like for you to kind of practice and, like I said, get really fluid at being able to do this. Okay, this last example was basically a class activity. If you're watching this lecture online, then chances are you didn't have an opportunity to do this activity as a class, so we'll just make up some numbers. In class, what I intended to do with the class was to poll the class about their favorite color, and then we would group them into a table like this where we count up how many people had a different favorite color or whatever. So we could do this. Let's say that some of the colors mentioned were blue, red, yellow, green, and purple. And let's say that there were 10 people who liked blue, maybe 8 people liked red, 7 liked yellow, 5 liked green, and 4 liked purple, something like this. Okay, so now to fill in the rest of the table, what I want to know is, I know that there were 10 people who liked blue, but what fraction of the class liked blue? What percentage of the class liked blue? So in order to get those numbers, what I would need to do is divide the number of people who liked blue, 10, by the total number of people in the class. And so I would need to find the total here, which I can do by just adding those numbers up in the Desmos calculator. So I'll do 10 plus 8 plus 7 plus 5 plus 4. That comes out to 34. And now to find the fraction of the class that liked blue, I would say, well, 10 people in the class liked blue out of 34 people in the class. So the fraction will just be 10 out of 34. For red, 8 out of 34 people liked red. And for yellow, it was 7 out of 34, and so forth. Now, it should be the case that when I add these up, I get 34 out of 34, which is just equal to 1. We can verify that in the Desmos calculator, right? So if I do 10 out of 34, now if I say plus 8 out of 34, notice that it's putting the 8 out of 34 here in the denominator of my first fraction, which is not what I want it to do. So I'm going to backspace, right, delete those numbers. And in order to get the cursor out of the denominator of that first fraction, I'm going to use the arrow key on my keyboard, and I'm just going to hit the right arrow to get the cursor out of the denominator. And now I can say plus 8 out of 34, arrow, plus 7 out of 34, arrow, plus 5 out of 34, arrow, plus 4 out of 34. And sure enough, that comes out to 1. To go from fraction to decimal, again, we just use the calculator. 10 out of 34 is about 0.2. Let's round to 3 decimal places. So we'll call this 0.294. 8 out of 34 is 0.235. 7 out of 34 is 0.206. 5 out of 34, 0.147. And 4 out of 34, 4 out of 34 is 0.118. And again, when I add these up, I should get 1, but it's possible, since I did some rounding, that I might end up with 0.999 or 1.001 or something like that. So we can double check. 0.294 plus 0.235 plus 0.206 plus 0.147 plus 0.118. I made a mistake. Oh, on the third one. I called it 0.260, but it should be 0.206. There we go. Oh, that's better. And then that comes out to exactly 1. The point is, you shouldn't get something too far off from 1. You can get like 1.001, and that's fine. But if you got like 1.3, like I was getting earlier, then you know you made a mistake somewhere. But anyway, we got a 1. Everything's good now. And now, to change the decimals to percents, we just move the decimal point 2 times to the right. This would be 29.4%. So 29.4% of the class has blue as their favorite color, right? 23.5% of the class preferred red, and so forth. And of course, when we add up all of those percentages, we should get 100% of the class. Okay, you can verify that by punching those numbers into your calculator, but that suffices for me. So that'll do it for this review.